Okay, here's our units 5 and 6 diagnostic for geometry. This would be coordinate geometry and locus. All right, so we have line segment AB has 2 endpoints, and we want the coordinates of the midpoint. So again, midpoints are about averages. You're trying to find the average, essentially, of the 2 points. So your midpoint formula is your x coordinates added up and divided by 2, and your y coordinates added up and divided by 2, otherwise known as this formula. This will give you the midpoint. So we can just do that. So I have my x1, y1, x2, y2, and x1 is 2a. So I'll cross that out. X2 is negative 4a. Cross that out. I like crossing them out because sometimes people get confused and put things in the wrong spot. If you cross them out as you go, you kind of avoid that mistake. Then I have negative 3b plus 6b over 2. And now I just have to do this. So 2a plus negative 4a is negative 2a. Negative 2a over 2 is negative 1a, comma. Negative 3b plus 6b is positive 3b over 2. And 3 over 2 is 1.5. So I get negative 1a and positive 1.5b, which is choice 2. All right, what is the length of a line segment with these endpoints? Length is a synonym for distance, in which case we use the distance formula. Distance formula is easy. It's the Pythagorean theorem rewritten a little bit. So if you have a squared plus b squared equals c squared, and you wanted to solve for c, c would be the square root of a squared plus b squared. So the distance is the square root of your x's difference squared plus your y's difference squared, because that actually gives you how much you changed in the x versus how much you changed in the y. Just to give you another visual of this, I have negative 3 comma 2 and 1 comma 0. So I want the distance from this line segment to this line segment. So again, your change in x's would be here, your change in y's would be here, and that's what's going in the formula. Okay, so my distance, so again, I would cross out here, square root of, I would label these first, x1, x2, x1, y1, excuse me. It's another common mistake. x2, comma, y2. And then I have 1 minus negative 3 squared. 1 and negative 3 are gone now, plus 0 minus 2 squared. 0 and 2 are gone. So I have distance is the square root of, and you have to be careful here, 1 minus negative 3 is 4. 0 minus 2 is negative 2 squared. And when I square positives and negatives, they always come out to be positive. So this is 16 plus positive 4. So I get square root of 20, which then, if you look at the answer choices, they're all broken down. So 20, my perfect square is 1, 4, 9, 16, 25, etc. 20 is divisible by 4. So I'll go square root of 4 times square root of 5. And the square root of 4 is regular 2. So I get 2 square root of 5, which is choice 4. Okay, number 3. Line segment AB is the diameter of circle O, whose center has coordinates negative 3, negative 7. What are the coordinates of point B if the coordinates of point A are 5, negative 10? So I have a circle. And I know that the coordinates of the center are negative 3, negative 7. So here's my x and y axis. Whoops, sorry. I have to move that way above here. Okay, let's say here's my circle. So my, let me move that a bit closer here. Something like this. My center is at negative 3, comma, negative 7. And one of my other diameter points is at 5, negative 10. So that's somewhere over here. And I want to get coordinates of B. So this is A, this is O, and B is over here somewhere. And if you notice, O is the midpoint of AB. So I can say, all right, well, A is at 5, negative 10. O is at negative 3, negative 7. And B is somewhere where we like to locate. And I could say, well, okay, how far does it go? How far do I have to go from 5 to negative 3? And the answer is I have to go down 8. Well, if I want O to be in the middle, I can repeat that to O and get B to be negative 11. I'm just taking negative 3 and subtracting 8 from it. And that makes sense from my graph. that B should be to the left of O. Okay, and we can do the same thing to the y coordinate. So I have negative 10 to negative 7. That's moving up 3. Do it again, and I get to negative 4. And that makes sense because B should be above O. So my coordinates for B are negative 11 comma negative 4, which is choice 3. Number 4, which is an equation of the line passing through the point 1 comma negative 3 and is parallel to the line whose equation is this. So I have my original equation, and I want to produce a line parallel to it. So I would like to solve this line for y so that I can actually read it off its slope. So I'm going to solve this for y by subtracting 8x. So we get negative 4y equals negative 8x minus 4. Divide both sides by negative 4. And so y is equal to 2x plus 1. So the slope of this line is equal to 2. And that's important because parallel lines have the same slope. So now I want to create an equation of a line. I want its slope to be 2. Parallel lines have the same slope. And I want it to pass through. It's got to have this point on it. It's got to have the point 1, negative 3. So the equation of the line is y equals mx plus b. M is the slope, so I can plug that right in. That's 2. And I know the point x comma y, 1 comma negative 3 lives on the graph. So if I plug in the coordinates, negative 3 in for y and 1 in for x, I can then solve for b, which is the y-intercept. I can algebraically find it. So I have negative 3 equals 2 plus b, and subtract 2, and b is negative 5. So I know my equation would be y is equal to 2x minus 5. Now, if I look at the choices, none of the choices actually say y equals 2x minus 5. However, one of the choices does solve to be y equals 2x minus 5. So if I look at the choice number 1, 2x minus y equals 5, if I subtract the 2x over, I would get negative y equals negative 2x plus 5, and divide both sides by negative 1, and I would get y equals 2x minus 5. And that matches what I have down here. So the answer is choice 1. All right, number 5. I have 3 equations of lines, and it's asking me which statement is true. Again, I would want to solve each line's equation. So I have x plus 2y equals 6. I'll subtract x from both sides. I get 2y equals negative x plus 6 divided by 2. I get y equals negative 1/2 x plus 3. A lot of people, this was actually a test question for you guys when we did this unit. A lot of people wrote negative 2 here. There's a 1 in front of the x already, and we're dividing by 2, so we get y equals negative 1/2 x plus 3. That's K. P. I have 6x plus 3y equals 12. If I subtract 6x from both sides, I get 3y equals negative 6x plus 12. Divide by 3. And I got y equals negative 2x plus 4. So that's P. This was K. And now we just have to get M, which I'll do up here. M was negative x plus 2y equals 10. I'll add x to both sides. I get 2y equals 1x plus 10 divided by 2. I get y equals 1/2 x plus 5. So here are my lines. This is M. This is K. And this is P. So it says, first statement, P and M are perpendicular. Well, if I look at the slopes of P and M, slope of P is negative 2 over 1. That's my slope. We're really looking at slopes for these. And my slope for M is 1/2. They are what we call negative reciprocals. They have the opposite sign and the fraction is flipped. Those are perpendicular. So that's actually the answer. Okay? Those are called negative reciprocals, and perpendicular lines have negative reciprocal slopes. Important fact to remember. Now let's just, for argument's sake, just rule out the other choices. So M and K are perpendicular. Well, the slope for K is negative 1/2. The slope for M is positive 1/2. They are negatives of each other, but not negative reciprocals. So that would be out. K and P are parallel. Well, K and P have reciprocal slopes, not equal slopes. Parallel lines have the same slope, so that's out. And M and K being parallel, M and K have negative slopes as well. I'm sorry, I should have said before, K and P have reciprocal slopes, and K and M have negative slopes. Only P and M have negative reciprocal slopes. So the answer choice is choice 1. All right, number 6. Which graph represents a circle with the equation x minus 5 squared plus y plus 1 squared equals 9? Things you have to know, the equation of a circle, it looks a lot like the Pythagorean theorem. The center is given by the numbers next to x and y, but those numbers are negated. So I have 5 and negative 1 for my center. The 9 is the radius squared, so I'd square root that to get the actual radius, which is 3. So I'm looking for a circle with a center at 5, negative 1, and a radius of 3, and my choice is choice 1. Okay, number 7. A circle is represented by the equation x squared plus y plus 3 squared equals 13. What are the coordinates of the center and the circle and the length of the radius? Center, there is no number being added or subtracted to x, so my x coordinate for the center is 0. My y coordinate is negative 3. And the radius, 13 is the radius squared, so if I take the square root on both sides, the radius would be the square root of 13. So my center is 0, negative 3. Radius is square root of 13. That's choice 4. 8. The graphs of the equations x squared plus y squared equals 36 and y equals negative 3 have how many points in common? Well, x squared plus y squared equals 36 is a circle. The center of that circle is 0, 0, and the radius is the square root of 36, which is 6. Y equals 3 is a horizontal line, a lazy line. And now I just have to graph them both. So here's my x and y axes. I have a circle with a center at the origin and a radius of 6. So here's my circle. And I'll say, well, okay, if that's my circle, this is 6, this is 6, this is negative 6, this is negative 6. And so therefore, y equals negative 3 would be a horizontal line right about here, down 3 on the y-axis. And so I get 2 points of intersection. 2 is the answer. All right, number 9, the equation of the locus of points 3 units from the origin is, well, interesting, we just did the last question. The origin is a point. I want all the points that are 3 units from the origin, which would be a circle with radius 3. And because it's a locus, we generally dot the circle. Not a big deal for this question, but for the more difficult ones, it might be. So here's my locus. My radius of the circle is 3. This is the set of all points that are 3 units away from the origin. And that equation would be x squared plus 9 squared equals 9, because we're squaring the radius. So that's choice 1. Okay, number 10. Number 10 says, which of the following states the equations of the locus 4 units from the y-axis? So I have my coordinate plane. Here's my x, here's my y. The y-axis is the given. I'll highlight it. This is my given. I want to go 4 units from that axis. So I could go 4 units in this direction and 4 units in that direction. Now, it wouldn't be just those 2 points. It could be any point on a line parallel to the y-axis. Because these points, any point on these 2 lines is also 4 units from the y-axis. So for example, if I selected this point, there are 4 units of distance. Or if I selected this point, 4 units of distance. So I want the equations of the dotted lines. Well, one dotted line is excited. They both are. So they're both going to start with x equals. And this one would be x equals 4. Every point on the line has an x coordinate of 4. 4, comma 1, 4, comma 2, 4, comma 10, etc. Every point on the line has an x coordinate of 4. Same thing over here, except every point over here has an x coordinate of negative 4. I'm just putting random points on the line just to show you. Every point on the line has an x coordinate of negative 4. So here are my equations of the 2 lines. Choice 2. All right, 11. Point P is on line M. So I'm going to draw line M. Here's line M. Okay. Point P I shall designate here. I would like to go 4 units from P and 3 units from M. So I'm going to highlight and I'm going to stop reading every time I get to something I have to address. So how many points are 4 units from point P? Boom, have to address that. 4 units from point P, the locus of one single point is a circle. So now I'm going to draw a circle. That's my locus. I'm going to dot it. I'm going to dot it. And I'm just doing that on the smartboard. I'm dotting it. And I know this is now as a radius of 4. So I know 1, 2, 3, 4. So this is 4 out. 1, 2, 3. This is 4 this way. And I want to go 3 units from line M. So line M was the original line we drew. I should have put the M in first. I want to go 3 units from line M. So here's 1 point. 1, 2, 3. Here's 1 point that's 3 units from line M. Here's another one. Well, so is this point. So is this point. So is this point. So is this point. That's forming a line parallel to the original. And the same thing can occur on the bottom. A line parallel to the original. So how many points are 4 units from P and 3 units from M? Well, they're points that are in the intersections of the loci. So here's my circle. And here are my lines. And if I look at the colors, there are exactly 4 locations that are green. That's where the yellow and the blue overlap. 1, 2, 3, 4. Okay? All right, next question. Number 12, I want to write the equation of the line through the point 4, 2, which is parallel to K. Line K connects the points 3, 6, and 5, 10. All right, so here's my equation of my line, y equals mx plus b. My goal is to find the slope and the y-intercept. So how can I find the slope? Well, I can find the slope by using the slope formula. So my slope formula is, slope, which is m, is y2 minus y1 over x2 minus x1. y2, I'll come over here, x1, y1, x2, y2. y2 is 10, y1 is 6, x2 is 5, x1 is 3. 10 minus 6 is 4, 5 minus 3 is 2, 4 over 2 is 2. So I have y equals 2x plus b. Now I know the point that has to go on the line is 4, 2. So I can plug in the 4 for x and the 2 for y. So 2 equals 2 times 4 plus b. So I have 2 equals 8 plus b. Subtract 8 from both sides. I get b is negative 6. And so therefore my equation is y equals 2x minus 6. All right, next question. In rectangle QRST, the slope of QR is x minus 1 over 4, and the slope of RS is 8 over 3. I'd like to find the value of x. A lot of kids got this wrong on the test when this was actually one of your test questions at one point. So if I have a rectangle, okay, so here's my rectangle. No matter what I do to that rectangle, if I flip it, if I rotate it, I get line segments. So here's I'll just call this QRST. I get 2 line segments that are adjacent, QR and RS, that are perpendicular to each other. And perpendicular lines have what we call negative reciprocal slopes. So if I know the slope of QR is x minus 1 over 4, and I'm going to write slope here, and the slope of RS is 8/3, I know that x minus 1 over 4 is the negative reciprocal of 8/3. So in this box must go the negative reciprocal of 8/3, which is negative 3 over 8. And then you get a very easy equation to solve. So I'll write my equation again. Here's the equation we're going to solve, and I will cross multiply. So we'll get 4 times negative 3 is negative 12 equals 8 times x minus 1. So I have negative 12 equals 8x minus 8. Add 8 to both sides. I get negative 4 equals 8x divided by 8. And I get x has to be negative 1/2. All right, next question. We want to write the equation of the perpendicular bisector of AB. A has the coordinates 1, 4. So here's A. and B is 7, negative 8. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. There's B. I want to find the perpendicular bisector of this line. Okay? So what does perpendicular mean? Well, perpendicular means we have 90-degree angles and we have negative reciprocal slopes. So first thing I have to do is find the slope of AB. The slope of AB would be y2 minus y1. So that's negative 8 minus 4 over x2 minus x1, which is 7 minus 1. So I get negative 8 minus 4 is negative 12 over 6, which is negative 2. That's the slope of the original line. The slope of a perpendicular line, which I'm saying is m with a little perpendicular symbol, is the negative reciprocal of that slope. The current slope is negative 2 over 1, so the negative reciprocal is negative 1 over 2. Okay, that takes care of the perpendicularness. Now, a bisector has to go through the midpoint. So for example, this would not be a bisector. This would not be a bisector. My midpoint, my line has to go through the midpoint. So let's do that. Let's find the midpoint. So for bisector, I need to find my midpoint. And then we're going to find the midpoint. So my midpoint would be, let's see. So I have my x1 and x2 over 2. That's 1 plus 7 over 2. And my y1 plus my y2 over 2. So 1 plus 7 is 8. 8 over 2 is 4. 4 plus negative 8 is negative 4. Negative 4 over 2 is negative 2. So my midpoint is 4, negative 2 right here. Now I could proceed a couple of different ways. I could do this graphically and say, all right, my slope has to be negative 1/2. So that means my line goes, oh, I'm sorry, I made a mistake. The slope should be positive 1/2. And I hope you can see that. A negative 1/2 slope would look like this. And then the lines wouldn't be perpendicular to each other. That's how I knew I made a mistake. So my slope should be positive 1/2. So from my midpoint, I'm going to go up 1 over 2. Up 1 over 2. And then I can do that backwards. I can go down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. And there's my perpendicular bisector. And the equation of this line would be y equals 1/2 x, that's my slope, plus my y-intercept, which is negative 4. Another way you could go get the y-intercept would be to actually do the algebra here. So I know my slope is 1/2, and I'm going through the point 4, negative 2. And I can throw those coordinates in. So I get negative 2 equals 1/2 times 4 plus b. I get negative 2 equals 2 plus b, and subtract 2. B is negative 4, and then I would get y equals 1/2 x minus 4 that way. Either way is fine. Okay, number 15, I want to write the equation of a circle with a diameter that has those endpoints. Let's see. So I have my endpoints at negative 6, negative 7. 5, 6, 1, 2, 3, 4, 5, 6, 7, and 10, 5. 1, 2, well, 10's all the way out. 1, 2, 3, 4, 5. So I want a circle, okay? I want a circle that's going through both of those points. I'm going to draw a little bigger and then scale it back. So roughly, and you can draw this in, here's my circle. That's pretty good. All right, so I need to figure out what the center of the circle is. That's what I need to figure out, and the radius of the circle. So if I connect the 2 points on the end of the diameter, I'll notice I have to get the midpoint of that segment. That will be the center of the circle. So center, whoops, sorry. I'm writing in, here we go. So the center of the circle is the midpoint of the circle. So, midpoint of the diameter. So here we go. Negative 6 plus 10 over 2, comma, negative 7 plus 5 over 2. So negative 6 plus 10 is 4 over 2 is 2. And negative 7 plus 5 is negative 2 over 2 is negative 1. So my center is at 2, negative 1. If you draw a pretty accurate sketch of this, you'll see that pretty well. Now the radius I can get a few ways. I'm actually going to get the radius directly by taking 10, 5, and 2, 1 and finding the length or the distance between them. So my radius is the square root, we use the distance formula, of my x2 minus x1, that's 10 minus 2 squared, plus y2 minus y1 is 5 minus negative 1 squared. And so my radius would be square root of 8 squared plus 6 squared. And that's the square root of 64 plus 36, which is the square root of 100, which is 10. By the way, you could have also used the distance formula on the entire diameter. You would have gotten 20, and you take half of that to get 10. So now my equation of the circle. I have something squared plus something squared equals the radius squared, which is 100. I have my x minus 2 squared plus y plus 1 squared equals 100. Remember, those coordinates are negated. Okay, a couple more questions here. 16. Parallel lines M and N are 10 meters apart. Point P is on line M. How many points are equidistant from M and N and also 8 meters from P? Holy moly. So we really have to read this one through. This is my first sentence, kind of a setup sentence. Parallel lines M and N are 10 meters apart. So here are my parallel lines. Here's 1. Here's 2. And I know that they are 10 meters apart. So I'm just going to here's 5 meters roughly. I just want to get an idea of where that would be. Okay, that's 5 meters. Point P is on line M, so I'll call this guy line M, and I'll say here's my point P. I want to be equidistant from the lines and some other stuff. So I'm going to take care of equidistance from lines M and N first. Well, if I want to be the same distance from lines M and N, I have to be smack in the middle. So here's one point, here's another 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 point. All those points are the same distance away from both the lines. And those points are forming a line themselves that's parallel to the original line, going 5 units away from both. Let me just move this up a smidge. Okay, good. And we want to be 8 meters from P. 8 meters from P. So 8 meters from P. P is a point. If I would like to be 8 meters away from P, I can go 8 every direction. So I'm going to go up first. I have to go past 5. Here's roughly 8 meters away. Here's another point 8 meters away, another point 8 meters away, another point 8 meters away. And I hope that you realize that those points form a circle. I'll just draw on the circle. And so now I'm looking for points that are both 5 meter or equidistant from the lines and on the circle. And if I look, there are exactly 2 places that got highlighted in green. Right here, right there. So there are 2 points total that work. Okay, one more question. So we have a quadrilateral. It has these vertices. M is -1, 4. A is 4, 7. Here's A. T is 7, 2. And H is 2, -1. And I want to prove that this is a square. So proving it's a square, I can prove it's a rhombus with some right angles. That's probably the easiest way to do it. So proving it's a rhombus with right angles, I want to get the distance of all 4 sides. So my distance for AB would be, sorry, not AB. We'll do MA first. MA. M has the points -1, 4, and A has 4, 7. So that's going to be, let's see, 4 minus -1 squared plus 7 minus 4 squared. So 4 minus -1 squared is 5. 7 minus 4 is 3. And so I get square root of 25 plus 9, which is the square root of 34. So now I know that distance is square root of 34. I'm going to do this for every side. So this is going to get a little tedious. I'm going to kind of give you the quick version here. So my distance is 7 minus 4 squared plus 2 minus 7 squared, which is 3 squared, which is 9, -5 squared, which is 25, square root of 34. Okay. Whoops. Uh-oh. Why are we not drawing? Okay, good. And TH, T was 7, 2, and H was 2, -1. So my distance there would be 2 minus 7 squared plus -1 minus 2 squared. So I get -5 squared, which is 25 again. I get negative 3 squared, which is 9 again. I get that, which is square root of 34 again. Okay, and I get, let's see, HM. This is my distance. Distance would be, I'm just going to do this one quickly without writing the points. I get 2 minus negative 1 squared plus negative 1 minus 4 squared. I get, again, 3 squared, which is 9, negative 5 squared, which is 25. I get square root of 34. So now I have a rhombus, but I have to also prove it's a square. And here's how we can do that. We can do slopes. And these you can count out if you'd like. My slope for MA, my MA slope is 1, 2, 3, 4. 4 over 1, 2, 3, 4, 5. I'm sorry, I messed that up. It should be 3 over 5. 1, 2, 3 over 5. So my slope is 3/5. And you can count it as long as you show the work. My slope from AT is, I'm going down 5 over 3. So my slope for AT is I'm going down 5 over 3. My slope for TH, I'm going, I'll go from H to T. I'm going up 3 to the right 5. So slope for HT is 3/5. And last but not least, my slope for HM, I'm going down 5. 1, 2, 3, 4, 5. Sorry, M's here. 1, 2, 3, 4, 5, and over 3. So MH is negative 5/3. Biggest thing here is to write your sentence, because you actually have to explain what this means. MATH is a square because all sides are congruent due to having equal distances. See, I'm bringing in my calculations here. Well, what did I show? I showed that all the sides have equal distances. And all angles are right angles. And why? Well, if I look at the slopes we just calculated, the adjacent sides, for example, MA and AT, have negative reciprocal slopes. Because connecting sides, or adjacent sides, people like to use the word connecting. Connecting sides have negative reciprocal slopes, making them perpendicular, thus forming right angles. And that would be a good model response. All right, that's it for our video. Thanks for listening.